So this is the second part of chapter 1. So last we left, we were talking about empiricism and how it relates to statistics. What we need to do next is get into the theory data cycle. So when we're talking about any kind of scientific method, and specifically about psychology, the best kind of science starts with a theory. A theory is a general understanding of how variables interact with each other. That leads to research questions, which will lead to a research design, which then ends up with a hypothesis, which gives you data. You either revise it or the theory, revise the theory, or it's supported by the data. So what do we mean by that? Well, let's take a very basic understanding of how this works. So one of the first theories, I guess the first one really in social psychology, was Norman Triplett's idea of social facilitation. So the theory is social facilitation. Social facilitation is a theory that says that the more people who are around, right, the better you are at doing a task. So if somebody else is there, you're better at doing the task than when you are alone. So listen to that theory. The theory is people are around, you do better at a task. Notice how that's pretty general. We're not talking about what specific task. We're talking about in general what happens. So we have research questions then that say, all right, well, so, how can we make sure that it's other people around and not just the task itself? Well, maybe that means we can come up with a research design that says we'll come up with a very simple task, and the only difference that we'll do is having somebody there or not having somebody there. This will lead us to a hypothesis. So, for example, Norman Triplett said, I think that people do better at a task when there's other people around. And that led him to say, all right, well, how can we make sure that this is exactly what we're talking about? Led to the research design, which was I'm going to have boys with a fishing rod. And because I know what I'll do is I'll just stretch out the fishing rod, and the task will be how fast they can wind it up. And what I'll do is I'll just measure how long it takes them to wind up the same amount of line when they're alone versus when they're with other boys around. That's it. That's the research design. The hypothesis is the specific prediction that they're going to make. So in this particular case, the hypothesis was if there's other boys around, they're going to wind up that fishing rod faster than if they were alone. Then he collected the data, and in this particular case, it supported his theory. So what we see is that the theory is a general statement of how the variables relate to each other. All right? Versus a hypothesis, which is a prediction of what you will observe if the theory is accurate. So the theory is the general idea, and then the hypothesis is specifically the prediction in whatever the scenario is you're giving them, the research scenario that you happen to be given. Theories are good because they can be revised through data. Often we have a problem, specifically in this class. In this class, you're going to have to come up with some research designs. You're going to have to come up with some ideas about, how things work and come up with an actual study, etc. And I know that some of you are like, oh, I know. I want to study Instagram because, that would be, oh, I want to study Snapchat. That'll be great. Snapchat is not a theory. Snapchat is not a theory. It's just something, right? It's a thing that's out there. If you get too bogged down in this idea of the research design, you lose the theory, the why it should happen the way it does. You need a why. You need a why it would happen before you're going to get into anything else. The reason why is because then, with that, you can revise it and then get more data to either revise it more or less. So, for example, let's talk about social facilitation some more. Social facilitation theory is the one that we talked about with Norm Triplett. People are around, the better you do. Well, some of you should be thinking right now, gosh, I know that if people are around, I actually do worse because I get so nervous and all that stuff. Well, so what they did is they said, okay, what about if you are not very good at the task that you've done? What about that? That's the research question that they said. That leads to a research design where they said, all right, well, we can give people difficult tasks and easy tasks and then see how well that they do. Well, what they did in this particular case, there's lots of different studies on social facilitation. Don't get me wrong, lots and lots. But one simple one is that they had people do a difficult task versus an easy task, either alone or with other people, and saw how that worked. So, for example, the task was to tie your shoes, which is easy, or to tie a complicated, like, it was kind of like a straitjacket kind of thing. It was actually like this vest thing that they had to tie up. They'd never done it before. They either had to do it alone or with other people. The hypothesis was that you would do better. According to the theory, you would do better on the task uh, if you did it with other people than when you're alone. But what they found is that it depends. So the data found that the tasks that were done with other people were done better only if it was an easy task, something they'd done before, like tie your shoes. If that was the case, then yeah, they did better when somebody else was around. But with the more complicated thing, they did better if they were alone. This led to a revision of the theory saying, hey, you know what? When we're talking about complicated tasks or new tasks, people do worse when other people are around watching them versus better when it's a simple and easy task. That led to the revision of the theory, which then can be applied to other things, et cetera, et cetera, et cetera, and leads to more understanding of how the world works around us. A good theory is one that is supported by data, falsifiable, and parsimonious. So, according to the scientific method, we are looking for that data. We're looking for that empiricism. We're looking for those concrete things that give us the data so that we can say, yes, here is the evidence that this is what's going on. And specifically, we're looking for evidence that can falsify. We want theories that are falsifiable. We don't want theories that are not falsifiable. Okay, we want theories that you can go out there and say, hey, I found that this is not really the case. Parsimonious means that they are simple as they can be. Occam's razor is that idea that the simplest solution is the best. Now, it's the simplest solution that actually works. So, for example, with social facilitation works works when there's a simple task, right? If more people are around, you do better if it's a simple task, but it's not that simple in general. So what's more parsimonious is to add on this next part. Well, if it's a more difficult task, then you're going to do worse. Even though that's technically more complicated, it's still the most correct. All right? So a good theory, supported by data, falsifiable, parsimonious. And one thing I want to mention with this falsifiable stuff is you never say prove when we're talking about the scientific method. For example, boy, this is important to me. When you are writing your papers, you will never say, thus we prove anything. What you're really doing is you are falsifying certain things, right? You're talking about the evidence that it is not correct. I don't know if you remember that idea of the null hypothesis, rejecting and failing to reject the null hypothesis. That has to do with this whole thing. You can say that something is supported, but we never say, thus we prove that our hypothesis is correct. Don't do that, because what we're doing is we're actually trying to falsify stuff, not actually prove that it's correct. I know that sounds kind of backwards, but that's really how it works in psychology. Okay. With this in mind, when we have different kinds of studies, the research that we do in psychology can either be basic, translational, or applied. Basic research is when we're going out there just to understand how stuff works. So, for example, I just want to know how the presence of other people affects your performance. That's the basic research. I'm going to skip translational. We're going to go to applied next. Applied is when you have a specific problem that you want to be solved, and so you do the research in order to solve that problem. Translational is taking basic research concepts and applying them to real-world problems. So, for example, the study that was done by Norm Triplett to see just in general how well do people do on a task when they're alone versus with other people, that's basic research. But let's say that you wanted to know, how to improve your employees' output per day. Well, if that's all you were starting with, that would be applied. But let's say that you had read the research about social facilitation from Norm Triplett, and you say, hey, I bet we can apply this stuff that we learned in the basic research to this new applied problem. That would be translational. So let me show you an example of a couple of different studies that look like this. So let's go ahead and take a look at some basic versus applied. So this is basic research. This is just one that I happen to have around. This is basic research about songbird behavior phenotypes. So what this is we want to understand parts of the brain and how they work. And specifically in this case, they're talking about application of learning about something like singing a song and how the brain works with a canary. And then they're going to try to apply it later on. This is called comparative cognition. Apply it later on to how humans understand with their brains. Okay, so this is totally psychological research, even though we're using canaries in this particular case. So let me get this up so you can see it. The abstract tells you what they do. Basic research is when you do your own study and you're doing it just to understand how stuff works. So, for example, we want to understand how the song circuit in a canary's brain works based off of how much testosterone is going on. It's not like we're there saying, hey, gosh, I've got this bird and I really want it to sing a Justin Bieber song. That's not what's going on here. We just want to know how that part of the brain affects this general idea and then what the circuitry is. Okay, that's basic research. We want to know for knowledge's sake. That's basic research. It's a lot different than when we're talking about applied research. So let me find my applied research one. Here is a study on click-through rates on Facebook for Facebook advertisements. So the problem was we want people to click on Facebook advertisements. That's the problem. So what do? Well, in this particular case, we want to see, hey, does having somebody of a similar age and gender in that advertisement make somebody more likely to click on the ad? And what they found is that that is exactly what happens, right? People are more likely to click on an ad if there's somebody of a similar age and gender to themselves displayed on the ad. The problem was we need people to click on ads. They did this study in order to figure out how to get people to click on more ads. That's applied research. Translational research is when you take something that you know from a basic research study and you use it in an applied setting. So, for example, if I had read about how social facilitation means more people around makes you more likely to succeed, and then somebody had a problem, which is I need people to have better output at work, I could say we can take this, translate it into a real world situation. It's translational research. Okay. If I want to know if consuming fish oil really makes you smarter, what kind of research would that be? This would be basic research. The reason why is because I just want to know for knowledge's sake. I don't have a specific problem. The problem is I need people to be more smart. The problem is I just want to know. I just want to know whether this affects that. That's it. Basic research. I want to know how to get consumers to buy more Lil Uzi Vert songs on iTunes. What kind of research is that? This is applied research. I start with the problem. I want people to buy Lil Uzi Vert songs on iTunes. That is the problem. So if I run my study starting with that problem, then that's what it is. If I had gone in there and said, hey, here's the problem, Lil Uzi Vert songs on iTunes, and I'd said, oh, hey, I remember learning about cognitive dissonance research and how cognitive dissonance makes people like certain things based off of effort justification, etc. And I think we can take that and translate it to this problem of Lil Uzi Vert songs needed to be sold on iTunes. That would be translational research. This is certainly not basic because we're not just saying, hey, I want to know why people buy stuff. That's the basic reason. That's the basic research. This is an applied research design. It would be translational only if it was very clear that we started with a basic concept and then used it to achieve an applied end. That would be translational research. So for this chapter, here's what we've learned. We've defined empiricism. That was in the first video. We talked about the theory data cycle, where you start with the theory, you get your research question, your research design, you end up with a hypothesis, you collect your data. Your data either supports or leads to you changing or modifying your theory. The role of falsifiability, parsimony, and proof. So parsimony is the same thing as our Occam's razor, simplify, keeping the most simple, parsimonious answer. Proof, we never say prove. And then knowing the difference between basic, translational, and applied research. That's what we've talked about with chapter 1.